Hi, my name is Franco Huang. Today, I'm going to present two Berkeley AI projects sponsored by Qualcomm. Those two projects are developed by 20 students that will be listed at the end. And the principal investigator is Dr. Alan Yang. First, let me introduce TAI. TAI stands for Teaching with AI. We are building a teaching agent for many different Berkeley courses. First, what is the problem for the education for now? I believe that if you are asking the student if they are using the LM when they are learning, most of the student will answer yes. But is the LM helping the education all the time? Maybe not. There are four problems that we are facing for now. First, for those LMs, how to ensure the safe and ethical behavior. Second, how to make sure that all of the answers are related to the curriculum. Third, we know that if you are just asking a LM, for example, ChatGPT, a homework question, what you get is just how to do that homework or just giving an answer directly, but how to support a complete learning flows. Fourth, if we have a good LM education service, how to deploy them and deploy them at scale. First, by our service, we can ensure the ethical and safe behavior. For example, as you can see in the bottom, here are some example for us to do the ethical check, to check for the educational purpose, and check if the student's question is related to the current course. By taking those seriously in our service, we can make sure that the student is always focusing on the education on our platform. Second, let me show you some of the examples from the Thai website. First, here is a scenario when taking the 61A course. It is an introduction course in computer science. As you can see, the user is typing to ask a explanation of a concept. And the Thai bot is generating the answer that successfully explain the concept with those reference. And those reference are also course material, which the student can open. Then the user asks the Thai to provide some of the exercise problem. And as you can see here, based on the reference, Thai can also generate some of the exercise. And at the end, Thai can also generate some hint for the student to start with to solve the exercise. Here is another example that is running on the Qualcomm chip. Here, the student is asking the same question to the Qualcomm server. And as you can see, the model running on the Qualcomm chip can also solve the problem successfully to answer students' question. Here is another example for a course in the language department. We are also showing three steps. First, to answer a question that is asking for a concept explanation with a answer with reference. Second, based on this knowledge, Thai can generate a exercise. And third, Thai can also give the hint for the exercise. So as you can see, all of the experience here are related to the course material and make sure that everything it answer is related to the course. And also it is very adaptive to the learning outcome of different courses, so that the teaching style may be a little bit different from different courses. And here is an example that is running on the Qualcomm service. As you can see, the answer is also having a high quality. And more than that, Tai not only can provide a service to answer some of the general questions, and as you can see, we are providing the reference. We also allow the student to open the reference and study through the course material on our website. So for the Tai service, it is also very easy to deploy on your local machine. With the repo in the middle, you can deploy them by one click and also convert course material for a course through one click. And also, it is free to customize and do some experiment based on our current pipeline. Then let me talk about Rover project, where we are translating from speech to a ROS command. As you can see at the bottom, imagine that you are an astronaut in the space where there's no cloud. So everything you can rely on is a local machine. In addition to that, with the suit you are wearing, you'll have a very fat fingers that prevent you to control the rover accurately. So how to control the rover then? In this project, we are designing a way to use the Qualcomm Android phone to translate the speech to the ROS command. So here is the example. Imagine that the astronaut is saying that, "Hi, Rover, move forward by 2 meters for me." And then the agent in the Android app from the Qualcomm phone will process that intention into and translate it into a ROS command that can directly execute on the rover and send to rover. With this concept, we built an Android app here. So the Android app have 4 main features. First, you can see on the left, it can have the real-time data update on the main screen so that you can access the cameras, access the occupancy map, and also some of the very important data. For example, battery, velocity, and coordinate. Second, the user can also use the voice control to interact with the rover. Third, we also design a way to use a manual control and also force to directly send the ROS command to the rover so that there are multiple ways to interact with the rover. And here is the demo.
Move forward for 2 meters. Turn left for 90 degrees and move forward for 2 meters.
Thank you for listening, and thank you for all the students listed here that contributed to the Thai team, and for all the students that were listed in the demo video on the last page that was contributed to the Rover team.